Today, I'd like to look at two different geometry problems. One of them is this. Given a plane and a point not in the plane, I'd like to find the perpendicular distance from the given point to the plane. The plane has a right angle direction, n. I'll call its components A, B, and C. The nearest point in the plane to point P I'll call R. It's worth mentioning even at this stage that the line that connects P to R is parallel to the normal vector because both of them meet the plane at right angles. It could be that vectors PR and N literally point in the same direction, or they could be 180 degrees in opposite direction. Taking a second point Q in the plane, form the vector from R to Q. Obviously, R to Q is perpendicular to vector N, so that RQ dot N is 0. Let me redraw this with the perspective a little bit more clear. Any 3 points can be put in a plane. So I'm not introducing any distortion or misrepresentation because of angle of view or anything like that. This right triangle is half of a rectangle, and we know how that relates to adding vectors together. If I form the dot product of both sides with respect to the n vector, we also know a distributive law. But we just mentioned a moment ago that RQ dot N is actually equal to 0. The second term is 0. I don't have to write it down anymore. I do know something about dot products, though. The dot product of two vectors is the length of the first one times the length of the second one, multiplied by the cosine of the angle between the two vectors. Since the angle between the two vectors is either 0 degrees or 180 degrees, it means that the cosine is either equal to 1 or negative 1. I can get rid of the ambiguity by just taking the absolute values of both sides. Then, dividing through by the length of the n vector, we get that the magnitude of vector p to r is just absolute value of pq dot n divided by the length of the n vector. These are all things that we'll know in a given scenario. For example, I'll take the plane to be 3x plus 2y plus z equals 1. I'll take my point P to be x equal 1, y equal 2, z equal 3, and I want to find the perpendicular distance from the point P to the plane. Literally, the distance between P and R as I have it here. I get the n vector by looking at the coefficients of the x, the y, and the z in the equation of the plane. I'll also need a point of the plane, which I'm going to call Q. I just need 3 numbers, x, y, and z, that make the equation for the plane true. And being as lazy as humanly possible, I'll let x and y both be 0 and z equal 1. Next, I need to know the vector from P to Q. But this is just one of our end minus start deals again, so this is easy to do. Next, calculate PQ dot n, which is the dot product of two vectors that we already know, so that will be easy enough to do. Lastly, I need to know the length of the normal vector, but again, this is a completely routine little calculation for us to do. We square the components, add them up, take the square root. The perpendicular distance from point P to the plane of interest is absolute value of PQ dot n divided by magnitude n. And this is the perpendicular distance. We could simplify this in a variety of ways, or we could just leave it like that. The second problem that I want to look at today is this. If I have a straight line, either in two-dimensional space or three, and I have a point P that isn't on that line, I'd like to find the perpendicular distance from the point to the straight line. Straight lines are characterized by knowing a point on the line and a vector, which I'll call v, that points along the direction of the line. There is some closest point on the line to point P. I'll call that R. Ideally, I'd like to find out where R is, and then I would just calculate the distance between P and R. The reasoning goes pretty much as before. There's going to be a closest point, I'll call it R, on the straight line, closest to P, that is. We'll pick another point on the straight line. Obviously, P to R is at right angles to V. Also, R to Q is parallel to V, and our parallelogram calculation is still valid. This time, though, I'm going to take the cross product instead of the dot product. We'll do the cross product with V, and using the distributive law that we've already figured out, the vector RQ cross V is the zero vector. This result looks very much like what we had before, except these are vectors, and what I want is, I want to extract the magnitude of the vector from P to R. What I'll do is, I'll take the magnitudes of both sides. The magnitude of the cross product of two vectors, though, is the length of the first one times the length of the second one times sine of the angle between them. But we know that PR and V are at right angles to each other, so I'll just go on and write the angle in as 90 degrees here. Sine of 90 degrees is 1, so in my equation I can just stop writing down that last factor. Then I can divide through by the length of the V vector, and we have managed to get our hands on the length of the vector from P to R without ever actually figuring out what the R is. It's almost like a magic trick. Obviously, we need to work an example of this as well. Straight lines typically are described by equations like the ones I've listed. I'm going to take a point P with x equal 1, y equal 2, z equal 3, and find the perpendicular distance from that point to the straight line. I need to know several things. Firstly, I need to know a point on the line. If I set t equal to 0, x will be 1, y will be 5, z 3. I can then form the vector from P to Q, doing the usual end minus start routine. A direction vector for the straight line is given by the coefficients of the variable t in this case. In this particular instance, the magnitude of the vector works out to be an integer. It's 3. That was just luck, though. The next thing I'll need to do is to calculate the cross product of p to q with vector v, but we've done this sort of thing a number of times, so this should be routine. Then calculate the magnitude of that vector. When you square -6, you get 36, so you'll have 36 plus 0 plus 36. The perpendicular distance is radical 72 divided by 3. I hope everyone's having a good day. I'll talk to you again soon.